Já estamos ao vivo no YouTube e agora eu vou abrir para as pessoas começarem a entrar. Boa sessão, hein?
So good afternoon, everyone, and welcome to this session of the Networking Fridays organized by their center. So today I have the pleasure to be moderating this session with Filipe Alves and Marc Fernandez, and we will be focusing on the nascent Atlantic Whale Deal project, which aims to understand pioneer solutions to mitigate ship strikes on whales in Atlantic waters. So the session today will outline the objectives of this project and will explain how to use innovative detection techniques and risk assessment tools to enhance marine safety and biodiversity conservation. So don't hesitate to ask your questions on the chat. We will address them after the presentation of the two speakers. And as far as I know, they will speak together. So they will do only one presentation and they will alternate each other. So without further ado, I will introduce them. So welcome both, Marc and Filipe. Thank you very much for being here.
Hi.
Hi, hello.
Both doctors come from the MARE Center, Marine and Environmental Science Center from Madeira. They are affiliated also with the Aquatic Research Network and the Regional Agency for the Development of Research, Technology and Innovation in Madeira, and the Faculty of Life Sciences in the University of Madeira. So Filipe has studied at the University of Algarve, and he holds a PhD in marine science since 2014. And his main focus of the research is the marine ecology of insular environments. He has done a lot of work, especially in the Atlantic waters, with emphasis on the study of population ecology, ecophysiology, diet, movement of large megafauna. He has collaborated with a lot of researchers worldwide, has lectured at the University of Algarve and also at Duke University, and has supervised dozens of bachelor, master, PhD, and postdoc students. He's active reviewer and editor in some journals and consultant for international policies and the Second World Ocean Assessment. Welcome, Filipe. And Marc, Dr. Marc Fernandez. I'm very happy to introduce him as well. He's a long-term friend of mine. We met each other here in the Azores for a long time ago already. He has studied in the University of Las Palmas de Gran Canaria, and he conducted his PhD here in the Azores, which was finished in 2018. His main focus of research is understanding the spatiotemporal ecology of cetaceans, and one of his main achievements on his career was founding the MONISAT project, which is a project that aims to compile whale-watching sightings here in the Azores in collaboration with whale-watching companies. So his work has focused a lot on leveraging the potential of this opportunistic data to improve cetacean research. He is an expert in art programming and ecological niche modeling, and he has recently led one of the projects, Intertawa project, to develop low-cost tracking devices for marine megafauna. So just a brief introduction also about myself. I'm Laura González García. I'm working in the Azores for a long time. Right now, I'm the Scientific and Technical Coordinator at Futurismo Azores Adventures. I hold also a PhD in marine science, and today I will be moderating this session together with these two fantastic speakers. So please, Marc and Filipe, the floor is yours. Explain us more about this Atlantic Whale Deal project.
Okay. Hi, I'm Filipe. We're sharing the same screen, so for those who don't know. First of all, I would like to thank first the Air Center for this invitation for the Marine Biodiversity Network Fridays. It's a pleasure to be here, to have the opportunity to share this recently approved project, works on whales conservation, try to make this a better world, better oceans. And also thank Laura González for moderating the session. It's a pleasure to be here with you. Okay, I'll try to explain, let's share the screen. And let's talk a little bit more about what is this Atlantic Whale Deal project. Okay, so next slide. So what is this Atlantic Whale Deal project? So this is an Interreg Atlantic from the European Regional Development Fund, the European Union. It's a project that started, we applied over a year ago. It was approved in the middle of last year, and this started on December 2023 and will continue for 3 years, so until November 2026. So it's not a long project, so we have to walk fast to make everything we planned to happen, but it's very challenging, and I like challenges. And this is a project from the Blue and Green Environment, AA priorities from the Greener Europe, and with a total budget of 3.5 million euros, with the 75% co-financing, and involves 4 countries. It's the 4 countries of the Interreg Atlantic area. For those who are not familiar with this program, so every project must address all these 4, must include all these countries, which are Portugal, Spain, France, and Ireland. So especially Spain and France, it covers only the Atlantic sides of these countries. And we have several partners. So we tried building up the project to include several partners, which is showing next, from several regions of this country. So not only from one specific location. So as lead partner, we have our DT and MARE, Marine Environmental Science Center, where Marc and I are affiliated. So we are leading the project, but we're just doing a small part of it. This is an overall a major task, and involving a major collaboration project where everyone plays a very, very important role. And sorry, but I have to mention all these 15 is not too much. So from Portugal, apart from MARE, our DT, we also have the government of the Azores, the RPM Air Center, which is organizing this networking talk. It's Fridays, networking Fridays, marine talk. So, and then we have CIMAR and the University of Porto from north of Portugal, Mar Ilimitado, which is a Delft watching and marine research private company in the south of Portugal. And also from Portugal, one very important, which is an associated partner, which is Atlantic Line. So we have 15 official partners and 2 associate partners, which I have to say it's a key player here, which is the Atlantic Line and Fred Olsen, which is from the Canary Islands. So because it's companies, it's the ferries. So we have to involve these stakeholders. Otherwise, it doesn't make sense just decision makers and researchers talking to each other. It's very, very important to involve this ferry, because the ferries, and something we learned from most of these operators, they want to contribute to this problem of ship strikes. So it's very important to have their on our side. So continuing with the presentation of the partners, we have in Spain, we have Locan in the Canary Islands, University of La Laguna from Tenerife, University of Las Palmas de Gran Canaria, also from Las Canarias, sorry. And we have Marine Research Center, Bottlenose Dolphin Research Institute for Northern Spain, from Galicia. And then passing to France, we have 2 partners, La Rochelle University and CNRS, and 2 from Ireland, Irish Whale and Dolphin Group and University College Dublin. And soon we'll explain a little bit which one is doing in the project. And still about the consortium, it's not something I learned through times and being in many projects. And my previous projects, we start working with marine biologists, working with marine biologists and marine biologists. And it's something that things evolve much faster, and we learn much more if we involve different topics, different fields, different experts. So this consortium involves physicists, engineers, oceanographers, veterinaries, biologists. Of course, cannot escape from the biologists on this project. The statisticians, designers, and the socio-economists from these 4 countries of the Atlantic area, with the goal of to benefit the society, because everyone here plays as a global actor. So, and very important here is that we cover governmental, non-governmental, academic, and commercial organizations. So it's super important to have all these inputs in the project. So before talking about the project itself and on its structure and its goals and work package and its methodologies, it's important to address what is the problem, what we had in mind when we started to think about this project proposal, if we're moving on or not. So the problem is very clear. There is the Atlantic Ocean as overall the global oceans. They address multiple challenges, including biodiversity loss and carbon sequestration. And this program that opened in the Interreg Atlantic was very clear about to try to fight this biodiversity loss and carbon sequestration. So having in mind what I will explain in the next slides, we talk about it's a perfect fit to submit this proposal, and likely it was approved. And it was good to know that different projects have been approved at European level, but not only to address this problem. But what exactly is the problem? So this has been acknowledged also by the United Nations on this climate action line. So biodiversity has been recognized as our stronger natural defense against climate change. So the Earth's land and oceans serve as natural carbon sinks, absorbing large amounts of greenhouse gas emissions, conserving and restoring natural spaces and the biodiversity they contain. So it's essential for limiting emissions and adapting to climate impacts. This is UN statements. So we try to follow on these statements and to build up our projects. So showing here a nice illustration from a recent paper from A.D. Pearson and colleagues published last year that illustrates very well here on the left, for example, the importance of these whales to the ecosystem. For example, and especially in the carbon cycle. So these massive animals, they have a lot of carbon in their bodies, and in their feces are super rich in nutrients, iron, phosphorus, etc. And these feed up the phytoplankton. It contributes to phytoplankton blooms. So contrarily to what was said many years ago through the whalers that say, yeah, the whales will eat all the krill in the world, and so it will cause a decrease in biomass and will lead to extinction. No, it's exactly the opposite, because more productive, more rich are seas with whales and marine megafauna in general, not only whales. So whales is just here as using this as apex predators, indicators of iconic species, but there are for sure others that have similar scenarios as illustrated here. So richer are the seas in megafauna, richer are the seas in overall, because it's the food web is all related. So more feces, more nutrients for the phytoplankton. And I must say here, phytoplankton, moving a little bit away of the whales, but it's all related with carbon, because phytoplankton produces 50% of the oxygen that exists in our atmosphere. So contributing to phytoplankton blooms are key. And if that was not enough, phytoplankton absorbs 40% of the carbon in our atmosphere, because the phytoplankton also needs this carbon to transform to oxygen. So as an example, we would need, for example, the 4 times the production of the Amazon forest. Like we would need like 4 Amazon forests to produce the same amount of oxygen as phytoplankton, just to put this in perspective. But and then from phytoplankton, it also feeds the zooplankton and all the food web, like small fishes, large squids, etc. Apart from that, in parallel, these whales, when they sink, when they die, their body goes to the sea bottom, which so the carbon gets deposited and sequestered on the sea bottom, which is also very benefit. In addition, I'm talking here about these vertical migrations, but these whales, they also move, especially these large whales, sperm whales, baleen whales. They move a lot between breeding grounds to feeding grounds. Breeding grounds usually in tropics, lower latitudes, to feeding grounds in the polar waters, in high latitudes. So these movements between latitudes and tropical to polar waters also contributes to the migration of the nutrients. So it reaches different environments. So, for example, thinking about the efforts of saving one whale in one tiny island, let's talk about the Atlantic, where the project is focused. It produces a wide scale effect of and contributing to save ecosystem or small part of the ecosystem on the other part of the ocean. But the whales are not only known for their role as oceanic engineers. Of course, they contribute to ocean's health, maintaining the equilibrium of the ocean. But apart from that, they have a huge role in also socio-cultural, music, arts, educational, spiritual, cultural identity, aesthetics. They have a huge role. For example, it's difficult not to talk nowadays about the financial or the economic aspect of anything in this world. So there was the International Monetary report, International Monetary Fund report from December 2019 estimated that one whale could worth about $2 million. Probably this is underestimated. It's very, very difficult to get accurate numbers, of course, but we should bear in mind that contributes directly to whale watching, for example, which is a massive industry growing up worldwide. Also contributes this phytoplankton and all the food chain explosion also contributes to more productive seas, which contributes to increasing fish stocks and fishing industry, which is evaluated in about $150 billion. So it's very difficult to do this exercise. Some researchers, some publications have tried to address this worth, but apart from getting a specific number, it's common sense that whales are not only iconic species contributing to evolving an easy species to attract and evolve everyone in ocean conservation, but it's all have a very, very important biological importance and ecological importance. So we know how important the whales are, but then there's other issues. We have to share the oceans with humans, and numbers are getting higher and higher year after year. So it's becoming difficult to cohabit healthy oceans with humans. There's a lot of threats. I will not mention here a lot of threats. Of course, I'll mention just whales. Like 85% of whales' biomass decreased due to industrialized whaling for over 2 centuries. That was a massive cause of whale reduction biomass. But nowadays they are facing many other threats. And one of these threats is ship strikes. So this project is very focused on addressing one of these problems and ways to minimize the reductions or chances of ship strikes. It's very, very challenging, and several other projects have also working on this same goal. We are not the first one. There are others worldwide, it's at the European level, US, and etc. But it's very challenging because we have to deal with whales that are not always visible at the surface, especially with fast ferries that move at very, very high speeds that the whales cannot detect these animals, or the boats, especially the ones that they're flying over the water and the whales cannot see where the sound comes from, or it's too fast. So there's a lot of problems. Sorry. Yet these all contributed for us as a stimulus to move forward in moving with this proposal. So in a few lines, I'll try. This is the problem in brief. After what I explained in this last slide. So ships and whales co-occur across coastal and oceans, thus requiring transnational cooperation between multiple stakeholders to prevent collisions and biodiversity loss. So the whales, they don't know any political border. So it is a responsibility of us all to contribute to this problem. So our main goal with this Atlantic Whale Deal project is to develop solutions to reduce ship strikes as enhancing carbon sequestration as an indirect method, given these whales' pivotal role in ecosystem functioning. So if we minimize ship strikes, even if it's 1 or 2 per year, where it's already a success and we're contributing to carbon sequestration. And in addition, our goal, because it's not only related with saving whales, but also in benefiting the society towards global sustainability and trying to involve the society as most as possible. So this is just here one slide, like could work as a advertisement slide, like a graphical abstract of the project, focus on whale detection technologies. The project covers much more than this. And here, this is where I pass the word to my colleague, Marc, who will explain you better what is that, or how do we plan to achieve these goals.
Thank you. Thank you, Filipe. Thank you, Laura. Thanks to all the organizers, to the Air Center for organizing this wonderful opportunity to share what we're doing. And as Filipe said, well, this was a beautiful and a challenging project that we had in our mind. We had this idea in our mind for a long time. Actually, this come from other proposals that were not successfully funded, and we received this challenge, and we pushed it forward, and hopefully it was approved. Now we can work on that. And now we are realizing, we already knew it actually, that it was a huge challenge, and it is being a huge challenge. So I will try to go a little bit more on the structure of the project, how we thought about it, because it's not only about technologies. It does involve a lot on technologies because it has to be, but it has other parts also that will support these findings. So it will help us to understand what's going on, and it will help us also to create useful tools. I mean, at the end, what we want to do is, as Filipe said, if we can save 1 or 2 whales per year, if we can avoid even 1 ship strike per year, that's a lot. If we can go farther, that's great. That's the objective. But let's start slowly, step by step. Let's go forward. Let's move forward, trying to upscale it afterwards. So the work package 1 actually deals with detection technology pilots. And why pilots? Because we don't want to put something in the water and we don't want to leave it forever. We want to test. We want to test different methods. We want to see how feasible are they, how expensive are they, and how reliable are they. So this work package will be led by Plocan, and it will be implemented in mostly in the Canary Islands, but also in other areas. And I will talk a little bit more about this part using this graphical abstract. So we will test 3 kinds of technologies. Does that mean that those are the only technologies available? No. Those are the ones that we decided that we can test in 3 years with budget available. That's all. We can go farther, yes. Hopefully we'll go. And hopefully there are other teams that I will share a little bit afterwards that they're also working on this. So we are not alone. There are several project funded in the UA that are looking at this problem. So we together, we can solve this. So first, we will try something it's a classical method. It's acoustic, passive acoustic. Fixed hydrophones, and we want to detect the whales. We want to see where they are. Try to locate them as much as possible with a good area to locate them, and then send these as fast as possible to the boats, to tell the boats, okay, you have here a whale, you can avoid it. Something very important, we don't think that the fast ferries or the ferries are bad here. They are not the bads on the history. They don't want to kill whales. No one want to kill whales. It's not their job. Their job is to put passengers or cargo from one side to the other one. So the thing that we want to do here is give them tools to avoid this problem. And that's why we are working together with them. And that's why, Filipe, it's very important for us that we have 2 associated partners that are actually ferry companies with cargo also. So that is a key point on the project. They are not the bad. They are just someone that are in the sea and they have this conflict with the whales in this case. So let's try to give tools to solve it. So one is the hydrophones. We will test different methodologies on hydrophones, and this problem of the hydrophones mostly will be directed to in the Canary Islands, because we do have a problem there that it's very well described. That's why we have also a lot of partners of the Canary Islands. We know there that there is a problem, there is a conflict between fast ferries, some lines of fast ferries, and the sperm whales. There are collisions. This is very well reported. This is very well documented. So let's try to test that, and let's try to see if it works. The other method will be thermal cameras. We will use thermal cameras in different locations. We will use different kinds of thermal cameras also. And this will be done in the Canary Islands. Of course, we have to test them. Actually, there is already a ongoing project testing the thermal cameras in the Canary Islands. So some of the members of the project are already working on the project. So we are not starting from ground zero. We are also starting from slightly advanced knowledge. So we are growing here. And we will test it in the Canary Islands. We will test it in the Azores. We will test it probably on mainland Portugal also. We will test it also on Ireland. So we will test it in different locations with different kind of boats, with different waters, to see how do they work. And let's see what are the results. We know that there are some people already working on that. We are in contact with them, and we are working together with them. And we also will investigate a little bit more also the satellite detection, how much reliable it is, what we can do. It is worth it to do it or not. There are some limitations we know on the real-time detection, but even so, it is worth it to do it. It's not. So let's explore a little bit more about that. Different partners will lead different parts. The fixed hydrophones is mostly led by Blocan, and also with the University of Las Palmas de Gran Canaria. The thermal cameras is mostly led by the University of La Laguna, Tenerife, and the satellite detection is mostly led by the Air Center in the Azores. So different partners with different expertises are leading different technologies. And what we did until now on this work package, well, you have to keep in mind that this project started in December. December, it's a very difficult month because everyone is on holiday. So basically, at the end, it started in January. But in January, we started very strong. We did our kickoff meeting of the project, and we also did a workshop, detection technologies workshop, when we invited a lot of external consultants from different projects that we are collaborating with. And because, as I said, and as Filipe said, we are not the first doing that. So we have to learn from the other ones. We have to include them in order to learn and to grow. And we want them also to collaborate with solutions as long as we can. And if there is no conflict, we should collaborate. So that's why we invited the Ocean Project, which is a partially European Union funded project. 3 members of the Ocean Project come to this workshop, and they help us a lot with their experience and their knowledge with the technologies they are now developing. Also, we had a member from the Live Sea Detect project on the Mediterranean that it's also focusing on different technologies for whale detection in the Mediterranean. We also have a member from the Save Whale project, which is a project that already happened. It was funded by the Ocean Care, that they managed to implement real-time detection hydrophones in the Mediterranean, and they were really helpful for us to understand what's going on, how useful it was, how they worked. We also have 2 members from a company, Hydrotwin, that they work with different kind of buoys and acoustic detection systems. And we also have a member from the Marine and Animal Remote Sensing Lab from the Woods Hole Oceanographic Institution, that they do have a lot of expertise on thermal cameras detection for whales. So we put together these people with the project members, and we closed ourselves 2 days on a room, and we discussed a lot of ideas. And this was our ground base. From here on, we are start building it. So we had some ideas, but we also want to discuss our previous ideas with these people that has the expertise on the field. So they did try things. So we wanted to know how real it was, what was their opinion, and of course to collaborate and grow together. But this project, as Filipe said, it's not only about detection technologies. Of course, detection technologies they play an important role because it's what it is. We need we need technologies to detect these wells, but there are tools that can be also very useful. And in this case, we want to do the risk maps and acoustic contamination assessment to better understand which are the most conflictive areas and how well we can predict these areas in order to inform the different navigation routes. So this work package will be led by the CNRS, a partner from France, with a lot of experience on species distribution modeling and density surface modeling. So basically to understand the habitat and the distribution and the densities of wells. And we will do many things. This picture here that you have here, it's a bit impressive photography. It's old photo from 2011, and this is an sperm well. And as you can see, it's clearly cut in. And this is one of the accidents that happened in the Canary Islands. So that's what we would try to avoid. To do that, we will use different techniques. And we are putting together here a lot of people working on that. We will use different, just for the ones of you that has a more technical background, we will use species distribution modeling, agent-based modeling, shipping noise propagation modeling, and reverse drift modeling. So basically, we will use different kind of statistical methods and ecological methods to try to understand where the wells are. We are collecting now different data sets all over the Atlantic, trying to combine all this data in order to produce different maps at different resolutions that can be used to assess when you cross over these maps with the shipping routes to say, okay, this is a critical area, this is not a critical area, this is a critical area these months of the year, on the other months of the year, it's not that much. So we want to give information as much as possible to the ferry companies, to the shipping companies, in order for them to avoid having these accidents. These accidents are not good for the wells and are not good for the companies. They are not good for anyone. So let's provide information, not only using detection technologies, but also we want to use this kind of more statistical approaches, and let's see how do they work. There are other projects working on this. Also, I mean, specifically on the Atlantic and Pacific areas of the United States, you have some projects working the safe wells on the California coast, and you have also the North Atlantic right wells on the Atlantic coast, that they also use this kind of approach. They also use technologies and risk maps. So we are learning from the others, and we are trying to do something improved. So we are learning from what they do and trying to, okay, let's try what they did, and let's see if we can improve a little bit some here or there in order to advance a little bit more. Because this is, at the end, this is a very complex problem. I mean, we know this is not to be solved probably in 3 years. We want to advance the knowledge, and we want to test things to see how this can be improved. But okay, once we have something that says, okay, you have a well here now, and something that says, okay, this month, it's a difficult month on this area, or this week, it's not good, there may be wells around here. Okay, how we can combine this? If we have this information, we have to communicate this information. If we don't communicate this information, if we keep this information for us, for scientists and for governments or whatever, then no one will be saved, no well will be saved. So this has to be communicated to the boats. This has to be communicated to the stakeholders, to the ones taking decisions at the field and also on the legislation. So that's Work Package 3, Interactive Tools for Ship Strike Mitigation, which is led by the Air Center. Here, the main goal is to design a user-friendly and accessible tool that can be used to inform the stakeholders. This is the challenge, to create something that will be used, that it's easy to use, that it's not too complicated, that it's beautiful. Yes, it has to be beautiful, but they can use that, they can actually be useful for them. We will use data from several sources of Work Package 1 and 2. So we will take all together and we will process this information to give a product. We had very nice and interesting discussions during the workshop, even if the workshop was not dedicated on this work package, because we have the Ocean project. It has one of the main goals, it's to create this kind of tools to communicate on an efficient way this information to the shipping companies. And this is, even if it seems simple, it is quite a challenge, because you have to think that a captain in the boat. It has a lot of work to do. They have a lot of things to do. And of course, they don't want to kill whales, but they want something easy that they can implement easily. So it will be a challenge, but we are up to that. I'm sure together we will manage to do something nice and hopefully useful. We will create different kind of analysis, graphic, real-time alerts, different ways to communicate that information to different levels of stakeholders and decision makers. But of course, we have to go farther, as Filipe said. Okay, there's many studies on not many. There are some studies on how much whale it's worth, but we need to know more, because if we really think that these animals are important, and we have some clues that this is true, but we need to understand a bit more on how this is true and which is this level. So here, the University of Dublin, the College of Dublin, will lead this work package on ecosystem services analysis. As Filipe says, whale pool, the identification of the whales, it's very important, at least as far as we know, but it's not the only thing. There are many things that can be implemented here, as Filipe said, on cultural level, spiritual level, musical level. It's a very complex and intricate question. So there is the work package. This work package will focus on that. This starts, if I'm not wrong, on the second year of the project, which we'll also learn from some of the lessons learned on the first year of the project. And we will do a lot of interviews and a lot of interaction with different kinds of stakeholders in order to better understand which are the ecosystem services, and we use metrics and different kinds of analysis to try to move forward on this topic. And finally, okay, we built all these things. We have technologies, we have risk map analysis, we have an interactive tool, and we have now also an ecosystem analysis, ecosystem service analysis. So we have to know if what we did is useful or not, and we have to deliver a plan on how this can be really implemented in a real world. And that's what we'll do on Work Package 5, which we are leading here at DT and Mare Madeira. So in this work package, we will summarize all the results, and we will produce some recommendations. That's why we also have some governmental partners here, because we want them to be in the project. We want the vision of a governmental stakeholder, what is good for them, what is not good for them. Also, we want the vision here from the shipping companies, what is good for them, what is not good for them. We want to know, okay, this method costs that much. Is this feasible or is not feasible for a government? So we want to understand all these things. We want to understand the economic viability, and we want to give guidelines for replication. We don't want this to die here. We want to go forward. So we investigate all the different ways that we have to do, at least as much as we can, because we have to think that this is a limited funded project and a limited time. Hopefully we will manage to do things, and hopefully the things that we don't manage to do here, we will do it in a future project or in collaboration with other projects. But we want this to be useful. That's a very important thing. We don't want to have a project that we did things and things get lost. No, we want to produce useful results, and we want, even if the result is that all we tested doesn't work, we want this to be available for the others to use it and to grow on that. And that's all what we have. That's all what we have to say here. And I think it's a nice wrap up for you to have an idea of what it's the mindset of the project, what it's the problem of that we are leading here, that we are dealing here, which it's very important, and what we thought it would be a good way to try to advance on this problematic and to try to give some solutions here.
Thank you very much, Marc and Filipe. You said that that's all that you have, but it's already quite a lot of work that you have in front for the next few years. So right now we do have some questions on our chat, and I will translate it to you. So Some of them were already answers to the presentation, which is already very good, but some others come, for instance, from Zachary Suhu, who says, which area or distance a nitro camera can cover? And this question was posted while Marc was talking about the different techniques that you may test. For instance, the thermal cameras, I suppose it's referred to on the boats.
Yeah, there are several studies. There is a researcher from the Woods Hole Institute that he was on the workshop, Daniel Zitterwart, and he has a lot of work on that. It's a huge amount of work. It's amazing, incredible. Depending on the conditions, because it depends a lot on the temperature of the water and the platform, depending on the boat, they can detect wells up to 4 kilometers. So they can detect a well on 4 kilometers. Even they can detect wells up to 2 kilometers in the fourth, I think 4 to 6. So it's not bad. It's quite amazing what they can do. They do have a very nice thermal camera, a very nice system. And basically what they do is they detect the well, they send the information to a human. I mean, they have an artificial intelligence system, then they send the information to a human. The human validates the information, and in 20 seconds, they have the information back to the boat, saying if it's a positive well or not, and they have a very low rate of false positives. So everything that they detect, it's almost a well, and they can detect up to 4 kilometers.
Wow, that's a huge number. I was not expecting such a huge distance from a thermal camera. Thanks for the answer. So another question comes from Fabian Baumgartner, and he asks, are you collaborating with MMAG, the Marine Mammal Advisory Group?
No.
No, we are collaborating with so many colleagues and institutions and associations, not in that group. I have contributed to the referring to the UCN specialist group, or it's another one.
So here is not specified, but maybe Fabian can.
But I think the answer is no to that one. For this project in particular, no. Yeah, but we are open to.
Yeah.
We are very inclusive and open to. It's impossible to reach everyone a priori, but feel free to contact us, and we have the pleasure to try to collaborate as best as possible with everyone.
And I think also that this is a huge effort, collaborative effort, because as you well said, whales don't understand about boundaries. So some more questions, again from Zachary Suhu. Do you have similitude between satellite and vessel tracker data?
Satellite and vessel track data?
Yeah.
Vessel track data, well, we use different technologies, but we can use IES data to do the vessel track. But this you mean maybe on the detection? Well, satellite is different than thermal cameras. Thermal cameras, I would say it's when you detect on board, it's more immediate. Satellite, you rely on the orbit of the satellite, so it depends if it's passing there at that moment or not. Even so, they can provide near real-time information. There are some projects on that also. I mean, and we are also building bridges on that because it's a very promising field, but I think, in my opinion, it still needs a lot of growing. I mean, thermal cameras are well established, let's say,
and cheaper, much
cheaper by now.
One of the problems of the satellite to work as a near real, of course, we can work in detecting areas, like identifying core areas. That's one thing. The other thing is working near real time. I don't think we are there yet, mainly because of the costs associated with the satellite imagery.
Thanks for answering that as well. So I'm reading, we have a lot of questions indeed. So I'm reading some of them, and they are wondering about if you're collaborating with some other applications. And for instance, this one from Dave Branigan says, will this project be working with existing applications such as Whale Alert? that have demonstrated the history of collecting and disseminating marine mammal info to mariners at sea. There are some other questions related to collaboration with some other applications that are already in place. Have you thought about that?
We had some talks, for example, we know the Sea Detect Live. Also, they collaborated with RepSet. Yeah. I mean, we are open to that. I mean, it's not that it's closed. The thing here, we are not working that much on creating apps to collect data. Here in this case, of course, the data collected can be passed through the apps, and of course, we did not start yet the interactive tools work package. It's a work package that needs to be started soon, but it's not yet started. So we are open to that. I mean, we don't have any boundary here. At the end, as Filipe said, and as you can see, this is a very collaborative and open project in the sense that we have many partners, and we want to learn from others. And if there is a tool that already works or not, and works for that kind of stakeholders, but not for the others, why not?
But one of the problems, of course, while alert and benefiting from citizen science informing where the animals are, it's very informative. It's becoming more and more popular. But one of the problems of, for example, someone is on a ferry and sees a whale and writes on the app, and how to get to that information to the captain, so in order to avoid to deviate from the whale or reduce the speed. That is challenging, but the most challenging is how to validate it. That's one of the discussions we have with Daniel Zitterbam, because as Marc is saying, they invest a lot in a system that takes about 20 seconds to validate not to have false positives. Because if you inform the captain there is a whale there, and then it's not, there is a whale there, after all it's not a whale, the captain after the third time says, I don't believe you anymore. And when they heard there is a whale there, it just continue their own course, because it might not be, or it might be. So it needs to be validated, and that is challenging. So that's why using the thermal cameras, going through a system, AI system that can somehow on a few seconds validate, or using human control node, that's super important. And using citizen science, it's still challenging. It's a promising field. I believe that in a few years we'll be able also to inform in real time, but it'll take some time yet. We are not there yet, in my opinion. But of course, they are super informative to collect data, to use, for example, to create risk maps and to feed the models. That for sure. For near real time, a bit more challenging yet.
I think that was one of the main conclusions, that you need a lot of data to train all these models and create all these outputs, the outcomes. And in fact, this relates with another question that we have on the chat from Fred Kursky, which is asking about the models that you will use to predict whale movement, and how will you apply artificial intelligence in the project? Which I think it's an overall question. It wraps almost everything that you have discussed.
Artificial intelligence will be used on the detection systems. Okay, will be used for the detection of the automatic detection and sending the clicks of the sperm whales acoustically, and also on the visual systems, the thermal cameras, and maybe on the satellite. We have to see it. But for acoustic and visual thermals, for sure. For the risk maps, by now we will use statistical modeling, classical statistical modeling. Classical. We can use boosted regression trees. We can use some kind of machine learning algorithms, but we will use classical statistical inference, basically. And we will use also agent-based models, which is very cool, because we will try to predict the probability of a whale to be killed by a boat. We will use different kind of statistical approaches, let's say on the risk maps approach and the work package too.
We still have a lot of questions, but I will choose some of them, because some of them are offering some new sources of help. For instance, Joel Richards says, well, she's wondering if you will be working with the International Maritime Organization, because last year in the Mediterranean Sea, a particular sensitive sea area, a tool from IMO was implemented in the Northwest Mediterranean to decrease the collision with marine mammals. So they implemented already that tool, and I suppose that she's suggesting just to expand the use of this IMO tool to the project.
We are not working directly with them. We are aware with them. Actually, I tried to contact them on the proposal, the phase, but we didn't get any answer. So, but I imagine it's normal. It's a huge organization. It's what it is. But we know the people that also working together with them, which is the people of the Save Whales project. So many of the solutions that they implemented, they are solutions that came from the Save Whales projects. So we are not in contact with them, but we are in contact with the Save Whales. Of course, if someone can build up a bridge with them, I mean, they are a very important stakeholder for this project. We just didn't, I mean, we contact them, but at some point we had to submit the proposal. It's what it is. We have these stakeholders and this is how it goes.
And also another offer of another suggestion from Helen Smith. She says, we, Belgian Ship Owners Association, are planning a huge campaign to create awareness amongst the ship owners starting in June. She has sent an email to José and will be interested to see where they can collaborate. So I guess, again, that talking with ship owners is also a very good way of spreading the word. I think all the people using the sea should be aware of these potential risks.
Exactly. Yeah. And we are here, and that's why we involved shipping companies and ferries companies on the project, because I mean it doesn't make any sense to do a project like this, as Filipe said, just between scientists. It's not for us, it's for everyone, and they should be a part of the solution.
And that links with another question from Natalia Espina Alvarez, which is asking, what are the main challenges to engaging the final users to use the tools developed within the project? I think maybe it's too soon, but you are already expecting some challenges.
Tackling decision makers, and it's always difficult. What's the main challenges? There's a lot. First, we have to use these friendly user like maps, which facilitates a lot of communication with political stakeholders. But I think one of the main challenges is to involve them. How to involve? It's to involve them from the very beginning. I think is key. So, for example, one of our partners, we decided to invite them, the PM in the Azores, because they work for the government, decision makers. So it's super important to involve them from the very beginning. They, better than anyone, can help us to work on Work Package 5, on the implementation plan, on the follow-up of the project. So I think communication and not just informing, but involving them, engaging them from the very beginning, I think is key and will help to address this big issue.
And I think this will be the last question from the chat, and then we will start closing. This is a short one, and I think it has been already answered during your conversation, but Carlos Garcia asked if you are collaborating with people from Argentina or South Atlantic.
We are not currently, because this was a European Atlantic project. So we mostly, I mean, that does not mean that we cannot collaborate. That doesn't mean that we can talk. But the partners we looked, it was mostly on the Atlantic area or European area. But of course, that does not mean that we cannot collaborate. And if they want to collaborate, and if they have good ideas or things that want to know, let's go.
Okay, so Marc and Filipe, thank you very much. I must tell you that the chat is moving all the time, and you have a lot of contacts written and emails and suggestions in there, in both chats, in the Q&A and in the other, so please have a look. And just one final question from me. When are you planning to give us more information? When will you explaining the advances of the project to the general community?
We expect to have some results in 2 years at least. So we start doing some tests this year. So by the end of 2025, we expect to have some the core of the experiments done, and the beginning of 2026, like some very interesting information. So data being converted into information already. So let's hope in 2 years we can be here again, sharing more conclusive information about what we propose here to do. It will be a pleasure to be here in 2 years.
Very good. So we will be looking forward. In 2 years, we will be asking you, how is it going? And I think that's all for today. So thank all the participants for joining this session. Thank you, Dr. Marc Fernandez and Dr. Filipe Alves, for your explanation about the Atlantic Whale Deal project. And thank you, their center, for organizing these amazing sessions. Thanks to all, and see you in the next session. Bye-bye.
Thank you all.
Thank you.
Thank you for all the comments.
Perfect.
Então, foi
Ok.
bem? Do vosso lado,
Poxa.
foi bem?
Muito interessante. Eu recebi um e-mail aqui que eu tenho que partilhar convosco.
Okay.